Hi everyone. Today you are learning right triangle trigonometry and SOHCAHTOA. Okay, and SOHCAHTOA is the acronym that we use to remember the trig ratios. Okay, so we have three trigonometric ratios that you learn in this class, and they are sine, cosine, and tangent. Okay, and so we write SOHCAHTOA to remember that the trigonometric ratios for sine is opposite over hypotenuse. For cosine, it is adjacent over hypotenuse. And for tangent, it is opposite over adjacent. Okay, and I want to do a couple problems in 2 on first to get you guys used to looking at these right triangles and trying to figure out what's opposite, what's adjacent, etc. Okay, so I'm going to write SOHCAHTOA on the side here. Okay, so in number 2, right, in relation to angle 48, we know that x is across from it, right, and so if it's across from its opposite, and since the hypotenuse is always the longest side, I'm going to go ahead and label the hypotenuse, and that means that 17 is adjacent. Okay, so in this example, we are given opposite and adjacent. So we come over to SOHCAHTOA and we're looking for something that has O and A. So you can see that O and A is part of TOA. So that means that we're going to do tangent. And this is how this works. I'm going to do tangent of the angle equals opposite over adjacent. And opposite is x and adjacent is 17. Okay, and so then we have to solve for x, which is pretty easy. I think you guys are prepared to do this, right? To get rid of divided by, we multiply by 17 on both sides. Okay, so now my equation is x equals 17 times tangent of 48. And then we plug it into our calculator. So this is the hardest part, is trying to figure out how to use the calculator. Okay, so I am going to do 17 times, let's see, 48 tangent equals 18.88. So about 18.9. And then I want you to write in 18.9 where x is and see if that seems like a reasonable number. And it does. So the really cool thing about SOHCAHTOA is that for the first time ever, you guys are able to be given just one side and just one angle in order to find the other sides and other angles. So it's actually pretty cool. Okay, so here's number 3. Okay, so number 3, let's label the hypotenuse. Okay, and then in relation to angle 67, which is the only angle that we're given besides the 90-degree angle, which isn't very helpful, right? X is across from 67, so it is the opposite. And then next to is adjacent. Okay, so I have labeled all 3 of my sides as opposite, adjacent, and hypotenuse. Okay, so we are given opposite and hypotenuse. So you guys come over to SOHCAHTOA, and we're looking for something with O and H. Okay, so is O and H, so it's going to be sine of the angle equals opposite over hypotenuse. And we do the same exact process. So we're going to solve for x by multiplying by 29 on both sides. And I get x equals 29 times sine of 67. And we'll plug it into our calculator. So 29 times 67 sine equals about 26.7. So x is 26.7, which seems like a reasonable number for this problem. Okay. Let's skip ahead to number 3. Okay, or sorry, number 5. So we are given the angle is 16. Right, I'll label my hypotenuse. The longest side you guys can see is across from the right angle. So this is the hypotenuse. Okay, and then across from the 16 is the opposite, which makes x the adjacent. Okay, so in this example, we are given adjacent and hypotenuse. Okay, so I have adjacent and hypotenuse. I'm looking for a trig function that has a and h. Okay, so a and h is cosine. So I have cosine of the angle equals adjacent over hypotenuse. Okay, we're going to solve for x. And x equals 37 times cosine of 16. Okay, so we'll plug it into the calculator. 37 times 16 cosine is about 35.6. Okay, so x is 35.6, which is smaller than the hypotenuse, so I think that's a pretty good value for x. Okay, let's do number 6. Okay, so we're looking at angle 58, okay, and across from 58 is opposite. You can see the hypotenuse is not used, and so next to the 58 is adjacent. Okay, so in this example, right, I have opposite and adjacent. Okay, so opposite and adjacent is O and A. Okay, so if it's OA, I'm going to use tangent. So tangent of the angle equals opposite over adjacent. Okay, so we have to solve for x, and this one's a little bit more complicated because we have to get x out of the denominator first. So to get x out of the denominator, I'm going to multiply by x. Now I have x times tangent of 58 equals 22. Okay, and to get rid of multiplication, we divide. So I'm going to divide by tangent of 58 on both sides. Okay, so in my calculator, x equals 22 divided by tangent of 58. Okay, so let's use the calculator. 22 divided by 58 tangent equals about 13.74, so about 13.7. Okay, so if I plug in 13.7 here, I think that's a reasonable answer. Okay, so that is how you solve for x in the denominator. Okay, let's do number 7, then we'll go back up towards the top. Okay, so number 7, I'm given the opposite again. Okay, do you guys see the hypotenuse is not being used? So that means that 15 is adjacent. Okay, so I am given opposite and adjacent, so OA. Okay, so hopefully you can see we're using tangent again. So tangent of the angle 51 equals opposite over adjacent. We will solve for x. Okay, so x equals 15 times tangent of 51. Use our calculator. 15 times 51 tangent is 18.52, so about 18.5. Okay, Okay, so let's go up to the top here. So it says give each trig ratio as a fraction in simplest form. In order to do this problem, the first thing we're going to have to do is find this distance PQ, right? It's a right triangle, so if we're given two sides of a right triangle, we can find the third side using Pythagorean's theorem. Okay, so PQ is a leg, so a squared plus b squared equals c squared. Okay, so x squared equals 50 squared minus 14 squared, which is 2,304. And we take the square root. X equals the square root of this number, 48. Okay, so I'm going to erase this and just put 48. Okay, and I want to do this in two different colors. So if I'm looking at angle Q, okay, so Q is my angle. Actually, I'm just going to use a Q like they do. So sine of Q, in relation to Q, 14 is opposite, 48 is adjacent, and 50 is hypotenuse. The hypotenuse is not going to change. Okay, so sine of Q is opposite over hypotenuse. Okay, so that would be 14 over 50, which we can reduce. Right, let's divide by 2. That's 7 over 25. Okay, cosine is adjacent over hypotenuse. So adjacent would be 48 over hypotenuse is 50, which is 24 over 25. Okay, and tangent of Q would be opposite over adjacent, right? Okay, my pen stopped working again. Yay. Love it when this happens. Come on. Opposite over adjacent, which is 14 over 48. So 7 over 24. Perfect. Okay, and so we're going to do the same thing, but from angle R. So now I'm going to erase the blue writing that I did, and we are going to do the same thing from angle R, and angle R is my angle now. So what is the hypotenuse? It's still 50, right? But now R, across from R, is opposite, and next to R is adjacent. Okay, so my opposite and adjacent have switched. Okay, so sine of R is opposite over hypotenuse. So 48 over 50, which is 24/25. Cosine of R is adjacent over hypotenuse. So 14 over 50, 7/25. And tangent of R is opposite over adjacent. So 48 over 14, which is 24/7. Okay. Good. Hopefully I explained that well enough. Now we can do the trig functions for no numbers. I think that it's easier to do it with numbers than without numbers. Okay, so sine of A is opposite over hypotenuse. Okay, so sine of A is A over C. Okay, if we're doing sine of B, right, I'm starting at angle B, that would be opposite over hypotenuse. So that would be B over C. See how it changes based on the angle? So cosine of A, so from angle A, B is adjacent over hypotenuse. Okay, but what about from angle B? Oops, I didn't mean to erase the hypotenuse. Okay, so from angle B, adjacent would be A over hypotenuse. Okay, and then finally, last but not least, tangent. So tangent of A is opposite over adjacent. Okay, so tangent of A across from A is A over adjacent is B. But what about from angle B? So opposite over adjacent. That'd be B over A. Okay. So, moving along. Geology. Shan used a surveying tool to map a region of land for a science class. To determine the height of a vertical rock formation, he measured the distance from the base of the formation to his position. So from the base of the formation to his position is 43 meters. Okay, and the angle of his vision to the top of the rock formation is 36 degrees. So what is the height? Okay, so from Shan's position, we are given opposite and adjacent. Okay, so if I write SOHCAHTOA on the top, right, which one of these is opposite and adjacent? Okay, so we're O and A is TOA, tangent. Okay, so we are going to do tangent of 36 degrees equals opposite x over adjacent 43. And solve for x. Okay, so x equals 43 times tangent of 46. 43 times tangent of 46 is about 44.5. 44.5 meters. Okay, the next question, we're talking about ramps. A 60-foot ramp rises from the first floor to the second floor of a parking garage. The ramp makes a 15-degree angle with the ground. How high is the first floor above the second floor? Okay, so if I write SOHCAHTOA, right, I know that 60 is the hypotenuse, and across from 15 is x, so this is opposite. Okay, so I know that I have O and H. OH is sine. Okay, so I'm going to do sine of the angle equals opposite over hypotenuse. And solve for x. Okay, so let's do 60 times sine of 15 is about 15.5. So x is 15.5, and is it feet? Feet. Perfect. Okay, so what if we are given two side lengths but no angle? Okay, so if you know the sine, cosine, or tangent ratio of an angle, you can use the inverse of the ratio to find the measure of the angle. Okay, so it says use a calculator to find the measure of angle B. Right, so I'm starting at B. This is my x. So in relation to x, hopefully you can see this is the hypotenuse. 14 is across from, so this is opposite. And 8 is adjacent. Okay, so if I'm using SOHCAHTOA, right, I have opposite and adjacent. That's OA. So here's how this works. I have tangent of my angle, which is x, equals opposite over adjacent. Okay, and so when we say the inverse of the ratio, we are talking about a button on your calculator. Okay, so x equals inverse tangent of 14/8. Okay, and do not call it tangent to the negative first power. That's not what that means. Inverse tangent, or some people call it arctangent. So inverse tangent of 14/8 is a button on your calculator. So we're going to do 14 divided by 8. Hit equals, and then inverse tangent. So second tangent equals. So I think I messed up. Let me try that again. Okay, so 14 divided by 8 equals inverse tangent. So about 60.25 degrees. And that kind of looks like a 60-degree angle. Okay, how about number 4? Right, so I'm going from angle B. Right, so this is my angle B. And I am given the hypotenuse and adjacent. Okay, so if I write SOHCAHTOA, I'm looking for the hypotenuse and adjacent, A and H, cosine. Okay, so cosine of x equals adjacent over hypotenuse, 25 over 30. Okay, so x equals inverse cosine of 25/30. Okay, 25/30 is 0.83 repeating. Okay, we're not going to round it because we don't want to round any intermediate calculations. And then second cosine is about 33.6. 33.6 degrees. Okay. Here we go. We're going from angle B, right? And we know that 39 is the hypotenuse and 7 is adjacent. Okay, so SOHCAHTOA. A and H again. Okay, so cosine of x equals adjacent over hypotenuse. So x equals inverse cosine of 7/39. Okay, 7/39 is this number. Inverse cosine. So 79.66. So x equals 79.7 degrees. Okay, so now they're going to try to make it harder, but I am certain that we can do this. Okay, so it says we're trying to find the measure of angle W, so I'm going to put an X here, right? This is my final goal. And because there's two triangles attached to each other, that's my hint that I'm going to start at the other triangle. So this is not going to work again. Come on, pen. You know you want to work. Yep. Sorry, guys. Gotta say, this is the most frustrating part of writing on the tablet. Okay. No? Okay. Let me plug the pen in and then take it out again and maybe it'll work. Okay, it works. Here we go. So let's find this side length first. I want to call this hypotenuse. Okay, because it is the hypotenuse. Right, and so across from 25 is 15. So this is opposite over hypotenuse. So that is opposite over hypotenuse is sine. Okay, so sine of the angle equals opposite over hypotenuse. Okay, and we're going to solve for the hypotenuse, right? So I'm going to multiply by the hypotenuse. I guess I could have called it x, oh well. So hypotenuse times sine of 25 equals 15. And I divide by sine of 25. So the hypotenuse equals this. Okay. 15 divided by the sine of 25. So 25 sine is about 35.493. Okay, and I don't want to round intermediately at all. Okay, so I'm going to just make sure I leave this up on my calculator. Just how it is. Okay, and let's find out what x is, right? So I'm given the opposite, right? Because now, in relation to this triangle, the hypotenuse is the opposite, and 22 is the adjacent. Okay, so O and A is tangent. So tangent of x equals the opposite over adjacent, and I know that the opposite is my hypotenuse over the adjacent. Okay, so if you need to, I can erase hypotenuse and put this 35.493 divided by 22. So x equals inverse tangent of 35.493 over 22. Okay, so I left that number on my calculator for a reason, because I didn't want to round. So 35.493 divided by 22 is 1.61, and now I'm going to take the inverse tangent. So second tangent is about 58.2 degrees. Okay, that's my final answer. Okay, 2 more word problems and we're done. A ladder leaning against the wall makes a angle of 75 degrees with the ground. Okay, so here's my wall, here's my ladder, and it makes a 75-degree angle with the ground. That wasn't a very good triangle, sorry. If the foot of the ladder is 6 feet away from the base of the wall, what is the length of the ladder? Okay. So it looks like we know x is the hypotenuse, 6 is the adjacent, right, because across from 75 is opposite. Right, so I'm given h and a. So, toa, right, h and a is cosine. So cosine of 75 equals adjacent over hypotenuse. So times by x, divide by cosine of 75. So x equals 6 divided by cosine of 75. Okay, 6 divided by 75 cosine equals 23.1. We were doing so good, pen. 23. Getting real tired of this pen. My finger can draw, but my pen can't. Good. Okay. Last but not least, let me plug my pen in again, which I shouldn't have to do, but it seems to make it work. Jaden is flying a kite and lets off 275 feet of string. The kite is 150 feet above the ground. Assuming the string is straight, what angle does the string make with the ground? Okay, good. So, here we go. Here is Jaden. He's flying a kite. Oh, Jaden's huge. Let me make him smaller. 275 feet of string. This is how big Jaden is. 275. And the kite is 150 feet off the ground. 150. Okay. I assume Jaden's even smaller than that, but whatever. Here's the kite. Okay. So the kite's 150 feet, 275 feet of string. What angle does a string make with the ground? Oh, I was wrong. Jaden's laying on the ground. I don't know why. He's flying a kite like this. Okay. X. Okay, so what do we know? 275 is the hypotenuse. X is across from 150, so 150 is opposite. So we have O and H. SOHCAHTOA. OH is sine. Okay. So, sine of X equals opposite over hypotenuse. Okay, and X equals inverse sine or arc sine of 150 over 275. Okay, so X is about 150 over 275. Oops. Equals 0.54 repeating. Inverse sine is 33.0557, so about 33.1 degrees. Awesome. Good job, guys. Keep up the good work. Bye.